Today we will review chapter 13 because we have finished that, and I will ask you to come up with a problem. By the way, the homework is due on Sunday. Right? In chapter 13, we learned vector functions. So I'll go over a few concepts. Suppose you are given a vector function, of space curve. How do you find out the tangent to the curve at a given point? And how do you find out the arc length from a given point to another point? All right, let's do the tangent line first. So for the tangent line, let's say you have a point where r is evaluated T naught. Then what is the equation for the tangent line? Well, you need a point and a direction. Right? The point is already given. What is the direction? Do you know how to find out the direction of this line?
Derivative of t.
Yes, just a derivative. That's your direction, right? And you can call it v. You can take a derivative and evaluate at t naught, so you get a one particular vector, no more variable. Okay. And the equation for the line is r naught, or say r t naught, plus the t. But this t is not that t. Okay, that t is for the curve. This t is the parameter for the line. So if you want, you can choose a different t, but if you are fine with the same variable for different meaning, then fine, this is your equation of the line. Okay. So like when you theta for different parameter, I mean for different curve, right? A circle or a spiral, etc. Here the t is the parameter for the line, not for the curve. And the arc length, say if from here to here, from t naught to t1, then arc length of this, L equals, remember? How do you find out the arc length from a point to another point?
So it's square root.
Yes.
And then whatever square is plus.
Can you say what squared? It's basically the Pythagorean theorem for all these segments. For each segment, it's a Pythagorean theorem. You just decompose it into x, y. But of course, we are talking about 3D, so you have x, y, z direction. You have to use the 3D Pythagorean theorem to find out the length of each segment, and add them together, and take a limit. So by taking a limit, it means you're not doing summation, you're doing integral, right? So what is the length of each segment? You have to find out, x, y, and z direction.
That's just dx over dt squared plus.
Very good. Dx over dt squared, or you can say prime squared plus y prime squared plus z prime squared, and then dt. All right. So that's sorry, you can read on okay. Now I let someone do a problem. suppose this is RT. And T0 equals 1. Oh, sorry, T0 equals 0. Find the equation for the tangent line. At T0. I can erase this, okay, because that's the thing you will use. Who can do this problem? Want to give it a try? Maybe you try first? This is the easy one, because if you wait, then it's probably harder. Yeah, okay, right. Actually, I already started for you in the first equation. Yes. Very good. Yes, perfect. Yes, but you need to write down what it is.
Yeah.
Yeah.
Yeah, I was just.
Because actually you're not done with V yet. You know, you have to evaluate V at T naught.
Okay. So.
That's right. Oh, that's not a 1. Yes. Okay, now I can plug in on that. This is the thing you put into V. No, V itself, you can look at the top. V actually is not just the thing you wrote first. V is the thing you wrote in the second line. Because V is supposed to be evaluated at T naught already.
Okay.
So that's V.
So this is V?
Yeah, this is V.
Okay.
You need to plug in R, T naught to R to evaluate the first point, the starting point. Yeah. That's the point where the line starts. So you see you have R T naught, right?
Mm-hmm.
So you have to evaluate what is R at T naught. R is over there, original one, right? You have to replace T by T naught.
Okay, so. Alright.
Yes, very good. Now you can finish your equation. Yes, that's right. That's right. Miss one thing. You look at the original equation. Yes. R equals, you miss a little thing. Look at here. You missed the T.
Oh.
Yes, that's correct. Very good. Okay, yeah, done? Yeah. Thank you. Okay, sorry. Yes, very good. Thank you. So, I hope you can follow everything, right? That's very good. So, to put it more logically correct, it's this. So, V equals this vector evaluated at 0, so it equals this. And R not equal this, you just put it together. Now let's find out arc length. Well, for the arc length, I need to change this a little bit, otherwise we cannot find the actual values. Okay, let's find an arc length. So you try to find this arc length. Oh, no, I'm sorry. Let me change this. Okay. Wait, what that one? Give me a second. I think it will work, sorry. Okay, so can try it now?
Look, man, I can go up there. I can't promise you that I'm going to be able to understand what I'm doing.
It's okay. You use the formula just erased.
Yeah. I'm just trying to figure out how to properly.
That's L equals integral, etc.
Yeah.
No, you have to take a derivative. Oh, yeah. Still right on that.
Yeah,
for sure.
that was a messy way to put that.
Okay. That's correct. That's correct. Okay. You should be careful when you write down that. It looks like it's e to the t squared, but it is not. It is e to the t then squared.
Right. Okay. Yeah. Okay.
You need to write on dt after each.
Oh, right.
Yes. Good. The minus sign I want to cancel because you
Yeah,
squared.
yeah, yeah.
You have negative t.
Right.
Great. That's correct. Okay, in general, it's impossible to continue, but because I chose this square root 2, it happened to be a perfect square inside the square root. Can you see what square would it be that 2 plus e to the 2t plus e to the negative 2t? Can you see it?
4?
No. You need still have e to the t somewhere. Okay, it's like this. Whose square would be e to the 2t?
Yeah.
That's my question. What square equals e to the 2t?
Just e to the t.
Yes, what square equals e to the negative 2t?
E to the negative t.
So if you add them together, e to the t plus e to the negative 2t, try to square it on the paper, on side. Just write down e to the t plus e to the negative t. Plus e to the negative t. And try to square it in the entire thing. Yeah. No, square, not square root.
Oh, right.
Square it. See what you get.
I'm gonna be honest with you, man. I'm not getting it.
That's
Yeah, like
x
really
plus
do.
y squared. Do you remember the formula for that? Do you remember? Parentheses x plus y squared. You'll get 3 terms.
Yeah.
Yeah, what's the 3 terms? X squared,
X times y.
x times y,
Y squared.
y squared, but not x times y. It's 2x times y.
Yeah.
Right? Yes? So apply here.
Yeah.
Uh-huh.
I'm a disaster
Two-
person right now.
No, fine. Are you trying to write down 2xy?
Yeah.
So 2 times the product of these 2 terms. What is the product of e to the t
Yeah.
and e to the negative t?
I mean, it would just be 1, right?
Yes, you're right. So
Okay.
just have a 2. Perfect. Okay, do you notice this happened to be inside the square root?
Yeah.
So you
So-
can take this square root.
Yeah.
Uh-huh.
Okay. Sure. Right.
And you
for
plug
talking
in
through that
T0,
with me.
T1.
Yeah.
No, you're right. I mean, you should replace T1, T0
Yeah.
by the actual number now.
Yeah, that's
Yeah, the actual number is here. Here. So write on,
Oh, right.
No, e to the t, not e to the...
Right. Oh, okay. I knew that. It was just, that was a typo. Or write it or whatever.
All right. dt.
Right.
Okay, then you just need to integrate that.
Yeah.
Yes, very good. Very good. No, there's
Oh, there we
the
go.
minus sign is all you need.
Okay.
Great. Wait, you should plug in 1 first.
Oh, right. I promise you, I understand how this
No,
stuff
no,
works.
no,
I'm just
no,
falling apart.
Yeah. And the last 2 terms is cancelled. Wait, is that plus?
Yeah, sorry.
No, e to the negative 1 is e, not e minus 1. E to the negative 1 is 1 over e.
You're right.
That's it. No, done.
Well, yeah.
Oh,
just
yes,
write out the
try
full
to cancel,
thing.
yes. Then they
So.
can.
Yes. There we go.
Very good. Thank you.
Sorry about that.
No, that's great. Thank you for explaining that. Actually, this part is quite challenging because I know. Actually, one of the homework is like that, but didn't have this too. How did you do that problem? Did you do it?
I have not done homework yet.
Okay. Yeah, this is like a homework problem, but it's more challenging. Great. Thank you for coming up. Now let me go over a few more concepts. The tangent vector, the normal vector, and the curvature. By definition, this is R prime normalized. So you take a derivative, then divide by its own length. And this, by definition, it's like that. T prime over R prime equals K times N. And N is the unit vector. So T is a unit vector, N is a unit vector. T point in the direction of the curve, and N point in the direction of this turning. So if you're turning left, then T point to left. If you're turning right, then N point to left. If you're turning right, then N point to right. And N point to the center of the turning. So you can see T is changing with time. So T is here, after a while T becomes there, then difference is a little bit to the left. That's why it's in the N direction. And how much, or you can say how fast is the turning is given by this curvature. Right, so you obtain this vector, and the direction of this vector is N, and the value of this, the magnitude of this vector is the curvature. So, for example, if you're given an R, then you can obtain this T, right, by taking derivative and normalize. And if you take a derivative again, you will get a vector, then divide by this again. This step, this is the velocity. Or you can say speed, because it's a scalar. So this tells you how fast it is moving, and this tells you how fast it's turning. So the turning versus moving is the curvature. So every meter you move, you turn 30 degrees. That tells you how sharp the turn is. Right? If you move a centimeter and turn 30 degrees, that means you're moving a very sharp turn. Right? So that's, you have to do this division. So suppose this is a motion. It's a spiral, but the spiral is in a x direction, right? Because x direction is growing and the y, z direction they are turning. So suppose this is the r. Can you find the tangent vector, the normal vector, and the curvature at each point? Just using this formula. This derivative after normalization give you t, then derivative of t divided by the same denominator will give you a vector. Its direction is n, its magnitude is k. Okay? You try it? Try this one there. I'll help you if you need. Derivative of cosine is not sine. It's negative sign.
Right?
Negative sign. Yes. Then you divide its own magnitude. Right? This guy divided by its, you need to find out its magnitude.
Okay.
Then divide that. Just find out this first.
Yes, but where was it?
Just write down what is r prime norm squared. Another squared, r prime norm. Just write down norm of r prime. Just write down this.
Okay.
Uh-huh. Yes, do you know how to compute that?
No, we'll go on the video.
It's a square root
Square root of it.
of the squares.
Okay.
It's it's just a magnitude of a vector. Mhm. Great. Very good.
Okay.
And you can simplify that. Well, you don't need to factor out, you don't need to divide this by 9. You can just factor out 9, yeah.
Okay.
It's, you can, 9 times, yeah, that's correct.
One.
Perfect. So that's your r prime norm.
Okay.
Then you can do the division to get your t. You can read the middle part.
Do I know the parenthesis or
Just write on this.
Right out? Okay.
T equals this division. Okay, great. Then plug in the vector and its norm. The vector is, I think you just wrote the first line you wrote. I start with a bracket. Very nice. And this square root 10 is to make this t a unit vector. Because now if you compute its norm, it will be 1. It's not square root 10 anymore, because you have divided it by square root 10, it's become a 1. Okay, great. So you found t. Now let's find n. And to find n, you just do this thing. Find out t prime and divide by the same denominator again. No, the derivative of 0. The derivative of 1 is not. Great.
No, you can touch that?
Yeah, you still have that because that's part of t. Okay, that's t prime, but we need to divide the entire thing by r prime again. So you write on, you just write on t prime divided by that. Write on a new line, t prime divided by r prime norm. Okay, then plotting the numbers and vectors. You can just combine the two square root 10 because they are both in the denominator. So you can just time them together. Very nice. So that's your k times n. Okay? Equals, not. Okay, n is a vector. So can you write down, or can you observe, how do you find out k and n from that? Do you know? Or you need a hint? N is a unit vector. So k would be the magnitude of this vector. And if you divide this by the magnitude, you get a unit vector, which is called n. So you need to find out the magnitude of the left-hand side. You just write down what is the magnitude of the entire thing. You know, this whole thing, the 0, etc., over 10.
What should I go over here? Should I just put K? Or
Yeah, k equals, very good. Yeah. K equals.
it would be 0 divided by
Yes, 0 squared. Wait, you still have the 10.
So why divide everything just by 10? Or should I do that beforehand? Or should I just...
Well, they're equivalent if you know what it means. If you divide a vector by 10, it means you divide each component by 10. Right? So if you put 10 inside the square root, then every 10 would be 10 squared in the denominator. Then you take a square root. So the 10 will be in the denominator without a square. So you can do the divided by 10 in the very end, or you can put it inside, double square root, square, then square root. But the either way, just divide by 10 in the end. Okay, then simplify the square root. You can use the space here if you want to make it. Very good.
Okay, we just do that?
Yes, but it's doing inside square root.
I know.
Yes. Great. Perfect. So that's your curvature. Okay. Then the last step is just to divide the thing to get capital N, the normal vector.
Okay, so divide this by K.
Mm-hmm.
Okay.
You don't need to write on that. You just write on N equals what? Very good. Then just simplify that. And the third. You can see what happens to the third.
First one,
Yeah. No, I mean, this 3 will cancel that 3. Do you see that?
Oh, these three?
Yeah, because,
Oh.
yeah.
Oh, okay.
To get something really simple.
Okay.
Done, that's it. Very good. Thank you. So once you obtain your t and n, you can check one thing. Where's the t here? And n. You can easily verify if they are unit vector. They are supposed to be unit vector. So for example here, we check the square of this square, this square, this square. Is it a 1? Yes, because cosine square plus sine square equals 1. Right? So this is a unit vector. Right? So that's correct. And this is a unit vector. The square of this plus square of this plus the square of that is 1 plus 3 sine square, which means 9 sine square, right? Then 9 cosine square, which is 1 plus 9, that's 10. So the numerator will give you a length 10, square root of 10. And then if you divide by that, you get a unit vector. So they're both unit vectors, so that's correct. Okay. And the curvature is, okay, well done. Okay. So I hope you can follow this step by step, and that's pretty much what you have in the exam. Well, with different numbers, but essentially the same thing. Okay. Let me write on something here, then I'll erase. So for the last part, we will review what is something called motion in space. Suppose you have a curve. Now I regard t as time, r as position. So the same thing we did over there has a physical meaning. This is the velocity. And its norm becomes the speed. I can still use v, but without the arrows to represent its vector. Sorry, it's a scalar, not a vector. Okay. And then now I can talk about acceleration. What is acceleration? Acceleration is v prime, right? The derivative of velocity over time. Or you can say r double prime, because v is just r prime. So if you take a double derivative and a second order derivative, then you get acceleration. And that's usually much easier than where we just did it here, because you just take it twice. You don't need to find its norm. The norm is the complication. Okay, so if you have this one here, then you get the velocity over there, acceleration here. And the interesting part of this is we can always decompose A into tangent direction and normal direction. The tangent direction is along V, which is along T, because T is in the same direction, right? And normal direction is along this N here. So you can write down AT times T plus AN times N. And this AT is the tangent component of the acceleration, and this AN is the normal component. And T and N are perpendicular vectors. They're both unit vectors. And AT equals this V prime. And this V is not the vector, it's the scalar. So it's the speed. How fast the speed is changing tells you the tangent component of acceleration. And AN is kv squared. And this thing is something we already know in high school physics. K equals 1 over r. So this is v squared over r. That is the centripetal force when you're turning around a circle. So put them together, you can say, if you're given r, then you can compute acceleration, tangent component, and the normal component of acceleration. And as a byproduct, we can figure out what the curvature from this. So sometimes this way can find out the curvature more easier than that way. But it depends. Now I will give you some examples. Let me erase this one. I need this. That part I still keep. Now, same thing, but just switch around. 3 go to the t part. So let's find out a few things. What is v? What is a? And then what is at? What is a? Okay, grab this part. Remember, v and a are vectors. And maybe around here too. And v is a scalar, which is just a magnitude of v as a vector. And at and an are the components of a. All right? So, you want to try? You want to try?
Oh, no, I can't.
Okay,
Not
then
this one.
we'll try. Okay, erase all of this. So we can start from here. One. Yes, that's right. Great. Very good. No, it's the v norm squared. Sorry, v norm then prime. You need to find out v first. It's not, no, if you do it this way, then it just means the magnitude of a. Right? You have to switch to the order. You have to find out the speed first, then take the derivative.
This?
Yes, but then you find out what is v as a scalar.
Okay. No.
No. How do you find out? No, it's not 10. 10 is last time. This time it's not 10. Oh, wait, you're right. It's still 10. Yeah, you're right. You're right. It's just a different way. You're right. So, yes.
So it's the derivative of this?
No, the derivative of v and the scalar. The derivative of speed.
And speed is?
Speed is equal to 10.
Root 10?
Yeah.
So 0?
Yes.
Okay. And it's v squared?
Yes, but that's not going to help because we don't know what is k.
Okay, so it's just...
Actually, we can figure out what is an from what is a,
this,
and then we can figure out what is k.
because this is 0, so...
Yeah, this is
the magnitude of this would be...
very good. Yes, very good.
1.
Yes, just 1. Very good. Perfect. So can you figure out what is k?
Yeah.
And the byproduct, can you tell me what is t with n?
T is R.
Very good. Yes. That is what we call,
Okay, that is root 10.
yes,
Okay.
which is what we call b. And what is n?
And is
No, you don't need to do it again because we already, and look at the a formula there. This, the one on the left side.
that one?
And there's the one in the middle.
This one?
Yes.
Okay.
Okay. If we know a, then we can figure out what is n. Remember, at equals 0, an equals 1. So what is n? Okay, you're plugging these two numbers you obtained into the formula. Can you tell me what is n?
Well, you want to solve it?
Not really, because you can pretty much read it.
Okay, 0, 10 over here. 1. This?
Yeah, so that is n.
Okay.
Right? So this way is kind of like a shortcut. You can just obtain n and t without those calculations. You can just take it derivative twice and just manipulate this result, and you can get all of the geometric information. Okay, very good, very good. Thank you. That's very nice. That's what I would like you to do in the homework anyway. And I think it's a time. It's perfect.